Thank you very much. I'm very happy to be here because GPD is my favorite conference. I'm Agnes Koltay, and I founded a facade engineering company in Dubai 8 years ago. In that 8 years, we managed to be involved in many interesting facade engineering projects, buildings all over the world. This slide shows buildings that we are involved with only in downtown Dubai. And one of these buildings is Skyview over here. I don't know if I have a pointer. I think I have, yeah. Sorry, this one, Skyview. I will talk about this building today in detail. We provided full-scope facade engineering and facade access consultancy scope on this project, and this is the core business of our company. This is what we do and nothing else. Skyview is a 264-meter tall twin towers. The concept design is from SOM. The local architect was Norr, and it's an Emaar project in Dubai. It consists of 2 buildings and a giant skybridge which connects them at level 52 to 54. Our involvement on this project runs from 2013 until today. The building will get handed over at the end of this year. How we approach every project at the beginning, we look at the whole facade and categorize it to system types. So typically on a tower building, we have like 4 to 8 system types to work with. This building, because of the magnitude of it, the complexity of it, the skybridge, the tourist feature, Skywalk on it, the car showroom next to it, the podium part, we have a lot more systems to work with. This is a typical floor plate. You see little balconies eating into the floor plate. I will talk about this very narrow balconies here in a minute. This is the tourist feature. It's a glass-floored skywalk. Tourists can go and have a view on the observation deck. This is another optimization exercise that we did at the beginning of the project, and we tend to do it on every project, to look at the modulation and to see how it fits with standard size materials, how it fits with practicality. This is a kind of a value engineering approach, which is something that we call value engineering, not something that you look at the final package and try to make it cheaper, but just to optimize the design at every step of the project to try to gain the best design for the function. You see here on the first drawing, the original layout that we got from the architects, and on the other side, the one that got built. It basically looks the same, but there are big differences. You need 14 extrusions to build this one, and you need only 10 different extrusions to build this one, therefore much cheaper. What we did is nothing scientific, just played around with the radiuses, the meeting points of the arcs, move it around until the floor plate fits into a more optimized geometry. Another very important optimization tool is wind tunnel testing, which obviously happening in big projects like that. On this project, it was done by RWDI, but on smaller projects, we actually have to push for it. It gives a lot of important information for the design team. We can pre-calculate and optimize mullion sizes and glass thicknesses based on this. The glass thicknesses may or may not vary all over the building. If it's a flat surface, you maybe don't want to play with it because you see a difference in shade. We were lucky with this building because the curvature allows for going for different glass sizes, and it was not only demanded by structural reasons, wind pressure, but also acoustics. Building is built in a very busy traffic junction in Dubai. and it has a public access area and also the swimming pool on the top. It's like an infinity pool. So certain areas are STC 45, STC 40, and the typical areas are STC 35. This can be provided by different gloss thicknesses. And then in the mullion design, you can take up that gloss thickness in different ways. You can play with the air gap in the IGU, you can have different mullion sizes, or you can have adapter profiles to take this up. The building is luckily clad with stainless steel. It's real stainless steel. There's a big difference in the final product in between aluminum-clad buildings, silver-colored aluminum-clad buildings, and real stainless steel buildings. I really like the shine, the shimmer that stainless steel can provide, but unfortunately it gets volunteered out from many projects. Skyview kept it. It's a pressed finish, which is the best for corrosion resistance. It's a 6W WL finish from Rimax. The gloss is Guardian. It's Guardian float with Guardian coating. It's silver 20 SS. Same glass that was used on Burj Khalifa, and that was a direction from Emaar, from the developer. So let's talk a bit about the facade systems. The building is predominantly unitized system. It consists of glazing with the stainless steel bands. And these are just a couple of drawings, the design that we provided in the tender package, and the final design that we built with the contractors. There were some modifications, some further development on this, but more or less the same concept got built. Some construction pictures, bracketry, and then the balconies. So these balconies are eating up into the floor plate. The balcony doors are opening doors because of the curvature of the building. Some of the doors can open outwards, but sometimes the balcony is so narrow it has to open inwards. You see on this picture the doors are fully glazed. It's flush glazed. It was specifically custom designed and developed for the project. It's not a existing door profile. And that brought some complexity for the inward opening door. So again, the detail that we tendered out and the detail that got built, some of these details got some improvement. Some of these details we had to compromise a little bit on the aesthetics to be able to build them. Like this one here, you see a bit of improvement. What got built is more glazed area and only the hinges visible. Here you see a bit of compromise. We wanted a smaller door sill than what we got at the end. So the top of the buildings, the two towers, the few floors above the skybridge, it looks like part of the tower, but in reality it's more like a little pavilion which was built on the top of the skybridge. Also, the floor plates are differing. They are getting smaller and smaller. So again, it was not very practical to use the same unitized system here. It's mostly stick system curtain walling to provide for different kinks and angles. So some details and some construction pictures. Then we have some special systems on the building. There's a big panoramic elevator that takes people up to the roof bar and to the tourist attraction area. The tourist attraction area consists of different features. One of them is the glass floor skywalk. And then we have this tension cable wall at the bottom of the building on both sides. It's a very big, very transparent cable tension wall. So again, some details. We went for a patch fitting design on the cable tension wall. Some pictures. And the same patch fitting was specified and used at the back for the panoramic lift, but in this case it was built over structural steelwork. The Skywalk area is basically a giant truss, and people are walking in the center of this truss. It's a construction picture. Currently, it's already glazed. Currently, there are some site water tests going on in it and finishing up the works. So you see the four members of the big truss, and then you see a bit of additional slab here. The glass doesn't run next to the edge of the floor area. It does not really have a structural or technical reason. It's more a psychological thing for those people who are afraid of height to give a bit of psychological comfort. They can go and walk on the solid area. Also, you see an external extension of the floor, and I will talk about that later. It's for cleaning and maintenance purposes. So some details. Obviously, it has a multiple layer laminated IGU at the floor. IGU, so we will not have condensation problems, and multiple layers, so it has enough redundancy for potential breakages, although it's calculated not to break. And then an interesting thing, the flying beams. So the building went through a very late design review. And very late, I mean, it was already tendered out, contractors were already appointed. And the building looked like as it looks like on this render. And during that design review, some features were introduced. Basically, the stainless steel spandrel panels are departing from the building, forming so-called flying beams. These flying beams are architecturally providing kind of a transition from the tower to the floor, and they helped the building. The building became better with this. But every time when, at a late stage, you introduce something to the building, it has a knock-on effect, and it has consequence, and when you solve that consequence, it again changes something and opens new problems, and then you have to solve these. So in this case, the obvious problem it caused is the cleaning system, the BMU access. These flying beams are blocking the access of the machine below the beams. And it was not that easy to solve. So let's talk about the facade access strategy a little bit. Again, the whole area of the facade has to be reachable by some means, not only for cleaning. Cleaning is the easier part, but for maintenance, for replacing the glass. And for that, you need some kind of winch coming from somewhere, lifting the glass. So there are several BMUs on the building. Each tower has one on the roof. Here you see a progress and the final version of after all the coordination with MEP and trying to optimize everything. This is what that machine looks like. And this is the BMU for the other tower, tower 1. Actually, this is tower 2. And then there are additional BMU systems because the skybridge is blocking access of these roof BMU machines to the area under the bridge. This was the machine designed before the design review, before the flying beams. It was already a challenge because the skybridge has heavy truss steelwork, and that truss connects into the building. It runs into the building to tie to the concrete core. The BMU machine has to fit through the holes of this truss work, and it was already calculated for the maximum space and optimized. When the flying beams got introduced here, we had to extend the reach, and then we had to calculate with a cradle that has a counterweight and has a pantograph element that can extend under the flying beams and reach the facade. This is much heavier, it creates much more momentum, so the machine size has to increase, but the machine size could not be increased anymore because it was already maximum. So after more coordination, we managed to move the track closer to the area and to solve some of the areas, and then we had to introduce, I think, 6 more additional small systems to reach areas which could not be covered by this machine. So it brought some extra cost on the building. This is the gantry system to reach, clean, and maintain the belly of the Skywalk area, and this is the access system for the Skywalk. For glass replacement, there's a special sled which can run temporarily on top of the Skywalk, and then they can pack it away. And for the size of the Skywalk area, we have this latch that I explained, and on top there are rails where the winch for the glass and the separate trolley for fixing the operator can run. Additional monorails for the bits and pieces. And then finally, I would like just to show some construction images, so please enjoy with me the progress of the building. This is an earlier picture from 2015 January. That's glass mock-up, different glass types. And then the towers got built. And then the most interesting part has happened, which was elevating the giant truss work for the bridge. It was the whole bridge was prefabricated in 5 pieces. They installed the 4 connection parts, and then the middle piece, which was by itself 165 tons lift over the time of like a week, going up slowly, has happened. We had no involvement in this part of the project. It's main structures work, but it's very interesting. So interesting that even Discovery Channel made a documentary film about it. More progress. And then some current pictures. And then I have another slide, this. This also goes on the building. This is a 7-layer SGP laminated low iron piece of glass, and then the other picture is one of my colleagues in SEDAC factory with a 16-meter long piece of laminated piece of glass. These are also going to the building. It's going to be a tourist attraction, and I was really hoping to be able to talk about this part of the building in detail now. I cannot, because although it was scheduled to be built end of March, it's not yet built, although the first pieces of glass is already on site, and we did a final load test on site with the assembled pieces last Thursday. So it will be lifted soon, and then it will be clad over. Hopefully by end of July it will be on the building. And next conference I can tell you about the design steps of this part. Actually, it was a lot of research and development work as well. So I think there should be at least 8-10 companies in this conference who were involved in this project, sealant company, interlayer company, SEDAC itself. Next time. So thank you. And I don't know if there's any questions.
Thank you, Agnes. That was a great presentation. There's a question back here.
Is it going to be lower reflective glass on the skybridge for the view to the outside
Yes.
at night?
Yes. It also has an anti-reflectivity coating. The Skywalk. The skybridge is three floors, and that's residential units and hotel apartments.
Great presentation.
Thank you.
Where are the materials being produced? And could you say a few words of your company? Are you overseeing the quality of the materials, or how do you work?
Okay, glass is produced in the UAE. It's Guardian Float. They have a float line in Ras Al Khaimah in the UAE. Stainless steel is coming from Outokumpu. Aluminium is coming. It's extruded locally and it's smelted locally. The base, the rock for it is coming from somewhere. What else? Sealant is coming from sealant factories. We can break it down to screws, but whatever is available in the UAE is coming locally. Whatever is not available coming from abroad. We are involved in overseeing quality, but it's more on a random basis. The every piece inspection is the responsibility of the contractor. This last slide, the tourist feature, that's an exemption. We looked at everything on that part of the project.
Are there any more questions?
The stainless steel cladding panels, what grade of stainless steel did you use on them?
Okay. That was a long research project. It's electroplated. It's a 6WL finish. The base material is 316L, I believe. But to be honest, send me an email. I give you the exact specification. It was 4 years ago. Can't remember. Yes.
I actually have a quick question myself. When you did the wind load study, did you find any surprises due to the shape of it in the development of the wind pressure?
Not really. The big surprise that people usually don't consider, but we know because we live in Dubai, is that all the buildings around Burj Khalifa have much higher wind loads than Burj Khalifa itself. And that's because Burj Khalifa was designed in a way and optimized in the wind tunnel channel and oriented to minimize the pressure on Burj Khalifa. But then Burj Khalifa is basically cutting the wind, which is coming from the ocean, sea, and creates all these turbulences which hits the buildings around. So while Burj Khalifa is up to 3 kPa, on this building it's up to 5.
Great presentation. Just
Thank you.
short question. The kink angles between the different elements, yeah? Because
Sorry, I cannot hear.
the kink angles between the different elements, and to how many did you do bespoke profiles for each kink angle, or did you allow for some flexibility in some of the profiles, and how many degrees did you allow for in these kink angles?
Yeah, we took the typical male-female unitized system allowance, which is 2.5 degrees. We calculated on that basis. So everything which falls into that 2.5 is one type of profile. The profiles are custom designed. I mean, we did not invent the male-female concept, but the actual sizing and the shape of it is custom designed for this building. And then we had another high-rise project not far from this building with the same contractor, and they managed to use some of the dice on that project as well.
Any other question?
Yeah.
Thank you.
Okay, thank you.
Hi there. Did you like what you just saw? If you did, why not like the video? Drop us a comment below, as well as share the video with others, since GPD is all about sharing. And to receive more videos in future, subscribe and don't forget to click the bell icon for notifications. Ciao.